statistical method. Univariate statistical methods are generally those with a single dependent or outcome variable, but as many independent or predictor variables as it takes in order to understand the dependent variable. The goal is usually, though not necessarily, to find some sort of substantive causal relation, not merely a statistical association whereby one thing's a theoretically predictable from another for reasons uncared for. In other words, we are generally using these statistical methods in order to find a story of the data, not just expectable average differences, but the reason or reasons for whatever differences or relations we find. And we're trying to apply these stories to larger populations based on what we find in the samples that we assume are relevant to those populations. A general theme of this course is that while statistics as practiced by most social scientists in Canada is largely a waste of taxpayer money, sound and swagger, signifying little and buttressing bullshit, the methods themselves are not to blame for this. And in fact, they are far and away the best tools that we have for preventing the proliferation of empty and biased nonsense that, on the surface, one might blame on the statistics themselves. Just like opposing sides in a battle might firstly think that God's on their side, and secondly be savvy enough to tell their soldiers this, and thirdly not learn from having lost battles that God may not in fact be on their side. Just like this, so too, researchers with ideas at stake will think that statistics is/are on their side, be savvy enough to report to others only those results that are apparently on their side, and they'll get very good at blaming imperfections in their measurements rather than learning from those measurements and their results when their wonderful ideas are not supported by the facts as they themselves observed them. Note that the metaphor started from the premise that researchers actually have ideas that they are testing. In my experience, it is frequently not the case that researchers, one, have a clear understanding of what they actually intend to test or how what they are doing will test what they intend to test. And two, it's frequently not the case that researchers understand the connection between the advanced methods used in testing and the conclusions that they draw from the results. And I'm not complaining about this. I'll tell you why. What does this mean for us? What does it mean that people do not seem to have a coherent plan or logical understanding of their own work? It means, thanks to the fact that research must be communicated thoroughly to be published, it means we can know more about someone's research than they do if we are simply literate in the statistical methods they use. We can even come to infer some of the researchers' biases that may not even be known to themselves by pointing out uninterpreted results, tests not taken, misinterpreted results, and where persuasive urging or moralizing language has been used to mask the fact that we can recognize weak or ambivalent results. The scientific method is with us because it is stronger than nonsense. Contrary to what the precious egos of the scientifically illiterate and innumerate majority of humans on Earth would like to believe, if something is nonsense, even if that something is precious to us, the scientific method can reveal it as such, as nonsense. By requiring methodological rigor, we protect ourselves from nonsense. But only in the long run. In the short run, we need to, at the very least, follow Sturgeon's law, which says that 90% of everything is crap. In the short run, we are stuck with nonsense that says scientific right on the box. But so long as proper methods of reporting are adhered to, we can say, like the wise Zen master, we'll see.
There's a little boy. On his 14th birthday, he gets a horse. And everybody in the village says, how wonderful, the boy got a horse. And the Zen master says, we'll see. 2 years later, the boy falls off the horse, breaks his leg, and everybody in the village says, how terrible. And the Zen master says, we'll see. Then a war breaks out, and all the young men have to go off and fight, except the boy can't because his leg's all messed up. And everybody in the village says, how wonderful.
And the Zen master says, we'll see.
We'll see about your results. Maybe. Maybe someone will come along and correct the researchers regarding their own research or interpretations. Maybe someone will show that their results fail to replicate, fail to generalize, or even are the opposite of what was originally claimed or reported. When you see at the end of a paper, more research should be conducted on this topic, the interpretation might be that the preceding study or work justifies further research. I would like to install or suggest the following interpretation of such phrases as further research is needed. Whatever was found could be nonsense, and only further research will actually tell. Yes, the scientific method lends legitimacy to nonsense, but its requirements, the requirements of the scientific method, are by far the best tool for catching out that nonsense in the long run. Let's break down some of this into more digestible concepts and examples. First, for the sake of simplicity, let's take it as axiomatic that reality is something that exists, and something from which we could exit if we ignore important aspects of reality, like falling pianos. Now, do you believe something? Or if that's too modern for you, do you act like you believe something? Anything. If this belief is specific enough to actually relate to reality, to have some inferable impact or relation to the observable, even if this impact is only on one's own behavior, then there are two possible realities. The first is that the belief is true, or accurate or useful enough to be said to be correct. The second is that the belief is not true, or not accurate or useful enough to be said to be correct. Note that the belief, I believe that splebs are flurbans, is neither true nor false. So that specific belief does not imply reality splits into two possibilities, because it doesn't say anything impactful or refer to something like behavior in observable space. When it does, then it's a belief that splits reality. From when we first develop schemas, our means for determining truth is simply whether it works, or whether, in Piagetian terms, it needs to be updated. Our beliefs need to be updated because they put us into disequilibrium with our environment. For those playing the deeper philosophical game here, the model here is non-foundational realism, or Charles Peirce's pragmatic epistemology. This would place us slash me neatly inside both the empiricist and the postmodernist traditions. And so there's Rich Rorty there reminding us that our truths, not being absolute ones, could be replaced by others, and our not liking that fact is cultural chauvinism. Anyway, where we have a belief, there are two possible realities. The belief is correct, or the belief is wrong. If you think the belief is somewhere in between, then you'd best be considering it wrong or actively seeking something better. Where research comes in is as a test of the belief. If we can test it, then we can determine which world we are actually in. Right? Yes and no. It's a probability game, and things actually get more undetermined before they get better. By assessing our belief, we actually add two more realities. Correct and incorrect still remain, because to have certainty, even if you have evidence, is axiomatically foolish. So we still have two realities. But now we also have correctness or incorrectness of our assessment or test. So the belief is right, the belief is wrong, our test is right, our test is wrong. So this splits the world into four possibilities. The belief is true and the test is good, and this is the true positive reality. The belief is true and the test is bad. This is the false negative reality. The belief is false and the test of it is good. This is the true negative reality. And the belief is false and the test is bad. This is the false positive reality. Continuing our pregnancy example, fortunately, continuing our investigations by using more tests does not necessitate our exponentiating the number of possible worlds, so long as our dependent variable constructs are reasonably similar. Further research simply informs, in this case, how likely we are to be in each world. Some validity and reliability concepts can be relevant here. If we have a lot of studies that all replicate a given result, it may indicate that that result is not a fluke, but it may not indicate that the replicable results are relevant to the conclusion or belief being tested. I reliably feel sleepy at the end of the day. My attributing this to aliens harnessing my energy to recharge their interdimensional transporter cells is either correct or incorrect, yet the consistency of my getting sleepy has nothing to do with the accuracy of that belief. Validity needs reliability, make no mistake, but reliability does not need validity. And in reality, with its things like suffering people and falling pianos, it's important to you. You need validity too, not just reliability. So correlation is not causation, but this might lead us to think that it applies only to data ran through Pearson's formula. It applies pretty much anywhere we're using statistical methods. The ability to infer cause is conferred to us through our methods of data collection and experimentation. How the world from which we grabbed our data was set up. Additionally, association does not imply any sort of actual relation between two statistically associated things, since the number of people on Earth is growing. For example, the number of adults that believe some silly to believe thing and that do something, let's say that's a silly thing to do, is also likely increasing. So there's more people, and they're increasing together. This silly belief and this silly action. And you could say, well, okay, but we could use proportions rather than absolute numbers, and so the problem is solved, that we just have coincidentally increasing numbers. Well, okay, so use the proportions of that silly belief and the proportions of those actions. Then they'd still be associated because they're decreasing together. Because I just said they're silly, so presumably they're on their way out. They represent decadence. So then they're related. They're still positive related. They're just going down. And so they are related. Just through the availability of the sheer number of people in the first case, absolute numbers in the first case, and through the increase in available better thinking and development and the decay of old ideas in the second case. 2. In this review section of the course, we will review how this is the case for any individual investigation, but also zoom out and contextualize this fact. Because if you have only a 1% chance of obtaining your results in the world where your variables are not associated, that means in that world we would get your results at least 1% of the time. In other words, we could have a lot of published results that tell us we're in world 2, despite our actually being in world 1. Suffice it to say, for now, that improbability of occurrence is not necessarily proof of anything. Finding a couple of 7-foot-tall people does not mean we're in the world where it's reasonable to expect to see them, or to plan to regularly encounter 7-foot-tall people. A related idea here that is especially relevant if you are using statistical significance to inform your decisions or your conclusions is the idea that if you make enough comparisons, divide your data into enough subgroups, and elsewise modify or vary your data grouping and your methods of analyses, you will eventually find something interesting, or what you expected to find, and even maybe something you hypothesized. Okay, 4. In neuroscience, the phrase is usually absence of evidence is not evidence of absence, referring to the fact that we might be missing some kind of brain damage or brain loss with our investigative methods that we might not be seeing. Some physical damage could exist, or some change in the brain could exist, despite our not seeing it. Your R program content for this lecture is these 2 videos. Enjoy.